In Math 20-1 today, we're going to look at topic 7.3, solving absolute value equations. This is going to be part A, and tomorrow we're going to take part B. Now, one way to solve equations, such as 2x plus 1 is equal to 7, is to graph two separate functions. We could say y1 is equal to the left side of our equation, 2x plus 1, and we could say that y2 is equal to the right side of our equation, in this case 7. Then what we're going to do is just find the intersection point of our two graphs. Where the two graphs intersect has to be a solution to our equation. So here we have 2x plus 1. If x is negative 2, 2 times negative 2 is negative 4, plus 1 is negative 3. If x is negative 1, 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. If x is 0, 2 times 0 plus 1 is 1. X is 1, 2 times 1 is 2, plus 1 is 3. And if x is 2, we're going to get 5. Now if I plotted these points and drew a line through it, and I plotted the other line, y2 is equal to 7. That's just going to be a horizontal line through y is equal to 7. Now what you're going to see is that it's going to have one point of intersection, and that's going to be at the point 3, 7, and that's going to be our solution, and that's where x is equal to 3. In example 1, solve these absolute value equations by graphing. We want to graph them manually, and absolute value of x plus 2 is equal to 5. We're going to say that our left side of our equation, y1 is equal to the absolute value of x plus 2, and we're going to say that the right side of our equation, y is equal to 5. Here the line of y equals 5 is already drawn. Now what we're going to do is we're going to pick some points. I picked negative 5, negative 3, or negative 2, sorry, and 0. I picked negative 2 because that's the invariant point. That's where the graph's going to turn around and go the other way. And that's going to be the bottom of our V on our absolute value graph. And then I picked one point to the left of it, negative 5, and one point to the right of it, 0. So if I drew those points or figured out what they're supposed to be, if x is negative 5, I'm going to get 3. Negative 2 is 0, and 0 is 2, 2 is 6, 5 is 7, and I can draw those lines through there. As I said, that's the invariant point, and there's going to be, appears to be two solutions, x equals negative 7, and x equals positive 3, and if we checked and substituted back into our original equation, you'd find that 5 is equal to 5 for negative 7, so that works. And we're going to find that 5 is equal to 5 for the right side. So that works. Here's our next one. B. The absolute value of x minus 3 is equal to 4. If we plotted our points for the absolute value of x minus 3, and we drew our line for y is equal to 4, we can see that there's going to be two intersection points. One of the intersection points is x equals negative 1. The other intersection point is going to be at x equals 7. If we substitute those back in, we're going to find that they both work. Negative 1 works, and there we have positive 7 works. Now we're going to look at example 2. Solve the absolute value of 2x minus 1 equals 5 algebraically. What we do when we solve these algebraically is we have to set up two cases. In the first case is where the 2x minus 1 is going to be a positive, and the other case is where 2x minus 1 is going to be a negative. So what we're going to do is we're going to start out by saying here's the two cases. 2x minus 1 is equal to 5, and the other one, the negative of 2x minus 1, has got to equal 5. Now, that means that 2x is equal to 6, and x equals 3. We can check it. by substituting it back into 2x minus 1 is equal to 5. This means that 2 times 3 is 6 minus 1 is 5. The absolute value of 5 is 5. That works. Now on the other one here, we're going to have the negative of 2x. And now we have to have the negative of minus 1, so that's going to become negative 2x plus 1 equals 5. Be careful with that. I'm going to subtract 1 from both sides. Now I'm going to divide both sides by negative 2 to get x equals negative 2. Now I have to substitute it to check as well. And I'm going to get the absolute value of 2x minus 1 is equal to 5. We always have to substitute back into our original equation. So 2 times negative 2 is negative 4 minus 1 will be negative 5. And the absolute value of negative 5 is 5. So both of those work. So the two solutions to this, x is negative 2 and x is 3. So we can circle them both. The next one asks us to solve 2x plus 3 is equal to 8. And this one is a your turn. So you can stop, finish it, and now we're going to go through and correct it. So we have 2x plus 3 is equal to 8, which means x is equal to 2.5. If I substitute it in, it works. And the negative of 2x plus 3 is equal to 8. And if I substitute in, I get negative 5.5 and negative 8. The absolute value of negative 8 is equal to 8 with my substitution, and that works as well. In example 4, we're going to take x minus 4 is equal to 2x plus 1, the absolute value of x minus 4. This time, we're going to deal with an extraneous root. So here we have the negative and the positive, two cases. First case is the positive. X minus 4 is equal to 2x plus 1. Take away an x from both sides, and you're left with negative 4 is equal to x plus 1. Take away 1 from both sides, and x will equal negative 5. And that's our answer. Check it. The absolute value of negative 5 minus 4 will be the absolute value of negative 9 equals, on the other side, I get negative 10 plus 1, which is negative 9. And now I end up with the absolute value of negative 9 equals negative 9, and 9 equals negative 9. Well, obviously that doesn't work, so that we can say then that x equals negative 5 is our extraneous root. That doesn't work. Now let's look at the other side. The negative of x minus 4 is equal to 2x plus 1. We still have to do the other side. Sometimes it works, sometimes neither of them work. So we have negative x plus 4 is equal to 2x plus 1. I can add an x to both sides. I can subtract 1 from both sides. And now I can divide both sides by 3 to get x equals 1. Let's check that. The absolute value of 1 minus 4 is equal to 2 times 1 plus 1. And 1 minus 4 will give me the absolute value of negative 3 is equal to 3. And since 3 equals 3, x equals 1 is our only solution. Here is another your turn. And after you finish this, you can go on and do the next 2 pages of your handout booklet, which will be a worksheet. So here we have x equals 2/3 on our left side, where we have a positive 3 minus x, and where we have a negative 3 minus x, we're going to end up with x being negative 4. When we substitute these values back in, check our whole number first. 3 minus negative 4 is equal to 2 times negative 4 plus 1. So I'm going to get the absolute value of 7. 3 minus negative 4 is 7, equals negative 8 plus 1, which is negative 7. So again, that doesn't work. Throw it out. Let's look on our other side. Let's check it. 3 minus 2/3 equals 2 times 2/3 plus 1. Well, 3 minus 2/3 is 9/3 minus 2/3, or 7/3. On the other side, 2 times 2/3 will be 4/3. 4/3 plus 1, which is 3/3, is also 7/3. So that works. So you have your assignment. Do the worksheet on the next 2 pages, and we're going to get ready for topic 7.3b tomorrow.